At the beginning, when time started, it already had 50 gallons in the tank. So you got your tank, you got 50 gallons in there. Anybody who's an artist, maybe you can,
Christian.
You got the artist in the room?
Christian.
Christian's an artist?
Yeah.
Really a shader.
Shader? Shader or shady? Or both?
TikTok
Boy, you're
artist.
probably both.
I'm a TikTok artist.
Alright, so we're gonna go a cylinder tank here.
Oh, that's great.
Alright, so we have
This is really great.
water. This is gonna be my water here. This is, you got water coming in,
Interesting.
and then you got water leaking out. Let's just go like that. Alright, there's my water. I was thinking of,
That's really great.
you know, sometimes you think about drawing like a faucet almost.
Yeah.
And I can't draw faucets, so it just looks
So this
like
is
inappropriate.
like-
So yeah, that's what you draw. Water in and water out. Alright, so this is, what, 8 gallons per minute? And water is leaking out at 1/2 T to the 2/3 gallons per minute. Alright, my beautiful artwork here. Alright, so you're trying to figure out how many gallons of water leak out of the tank from the time t equals 0 to t equals 10. Alright, so in this particular case, we just want to know how much is leaking out. So we don't care about this one, because that's what's coming in. We just care about how much is leaking out from 0 to 10.
So the integral of that equation.
So the integral, because anytime you talk about like accumulation, like how much you have total, that's dealing with the area. Alright, so in this case, we want to look at this function, and we want to multiply it by 10 minutes, right? So really, you're taking gallons per minute and multiplying it with minutes, because you want to find how many gallons there are. So that goes back to when we were looking at the function, like if this was gallons per minute, and then this was minutes, and this was my function here, whatever it is, the area, the accumulation from 0 to 10 would represent the number of gallons. So that involves an integral. So in this case, for part A, you're going to integrate from 0 to 10 of that function. So what was it, 1/2 t to the 2/3. Alright, so now somebody has a calculator. Can you tell me what that answer is?
Oh, because you can do calculators.
Because you can
That's
use a
right.
calculator here. Sure.
Wait,
Then I-
what?
Then I will.
Which? How do we use this?
You taught us this yesterday.
Yeah, what's up? Oh, yeah.
I'll come in for 2
I mean, it's not hard. It's really math time.
Alright.
Alright, so somebody do it for me. Come on.
Lucy's doing it.
I'm
Right back there. There's
what?
like 30
Slowly.
calculators over there.
1/2.
We have 3 more problems to do.
I want to challenge her.
Wait, we do.
Shut. She should have done it in her head.
Yeah.
No, that's not.
I mean, you can do it without the calculator if you want to. It's just a power.
Oh, yeah. 2/3,
Okay. Wait. Oh no. I want
5
do
thirds,
it. 9.
So
and
3
then
fifths.
3/5. So
3 tenths.
3/10 t to the 5/3.
I want to invent my new.
Plug in 10.
I'm gonna invent a new pasta.
You know, 10 to the 5th power and take the cube root of that,
Alright.
Got that?
So
13.9247.
I was working on it.
13.9247.
9247. Or 48 or what? Or 925.
Alright, so for part A, at 10 minutes, that's how much is leaked out. 13.9247 gallons. Alright, so that's for part A. So if they ask you like how many gallons, you have to look at what's given to you. So if you're given a rate, that's one of the keys. Like you're given a rate, and if they ask you for just gallons, look at the units. I'm going from a rate to an actual, just, I don't know what you call this. Somebody help me out. Just a regular unit, regular old unit. All right. And so in this case, I have to go from here to here. I have to take the antiderivative. So that should trigger in my head. I have to take the integral. And so that's what you have to do for part A. All right. For part B, same idea. So how many gallons of water are in the tank at time t equals 10?
Well, you start with 50, and then you subtract.
We start with 50.
Subtract that number.
We can subtract that number because that's how much is leaking out.
Add 8 times 10.
And add 8 times 10.
Wait, what?
Right?
So
Yeah, wait, what? Alright.
starts at, oh, okay.
So think about it. So how many gallons of water in the tank? So we're starting, so the initial amount.
Wait, is that it?
Yeah.
Yeah, she said it correctly.
Yeah.
This was 50. We'll start with 50, right?
Try to reach.
Alright. You have a certain amount that's leaking. And we already calculated that from part A. So you're going to take that part away. So we're taking away 13.9247. And then we're adding, the water going in, pumped in. Alright, and so in this case, we got 80 because it's 8 gallons per minute
For 10 minutes.
for 10 minutes. Alright, so 8 times 10. Alright, which gives us that 80. And then if we calculate this out,
116.0752.
116.0.
Whoa.
752.
752. And that's how many you have.
You did,
Nice.
Yeah.
Yay. Okay.
It's just subtraction.
Oh, an expression.
Alright, so for C though, it said, okay, well we calculated out,
Each one
but
had to
what would
erase
the
it.
expression actually be? Alright, so for the number of gallons of water in the tank. So if it said, write the expression F of T, well we're going to do what you just said. This one right here, what do we start with? 50. We're going to subtract what was leaking out, but we're writing the expression for it.
So,
Alright, because this is for any value of time. So not at 10 minutes, not at 30, not at 90, like just T.
so
So the
minus the
integral of-
integral
So the integral, there we go, from 0 to
t.
T of, well, the function that we just had.
Yeah.
1/2 T to the 2/3 dt
Plus 8t.
plus,
8t.
you can write it as 8t.
Yes.
What's another way you could write it?
That's the easiest
T
way.
times 8. What's
T
how do you write with the
over
integral?
1/8.
Just to make sure we're on the same page.
Oh. The,
Oh, well, the integral.
You could also write it as,
3 times the integral of 8 gallons per minute.
Like the integral, so 0 to t and just 8.
oh, but that's like,
Okay.
it's the same thing. When you take the integral of this, it's this, right?
Yeah.
Same deal. I'm just saying,
oh,
knowing that these two are equivalent to one another.
Did you do that?
Yeah.
I just think about like if, like multiple choice.
probably.
This one might be right. You might have this answer choice. You might have the one where they're both integrals. So just knowing that they are the same thing. But that is definitely correct.
Probably.
All right, and so that's what you get for C.
Yay.
So you got the initial amount, how much leaked out, which again involves an integration, and how much is pumped in, which in this case, since it was a constant rate, didn't really matter. But also, you can involve an integration expression there. All right, and that leaves us for the last one. We'll get out of here. So at what time t from 0 to 90 is the amount of water in the tank at maximum?
Do you have to derive it and then make a sign chart?
Now, why would you even think that?
Because you find
I
maximums.
didn't mean to say it like that, but
Because you
Why?
find maximums by taking.
that,
the
there we go. That's the
derivative.
key. Maximum. You see maximum here. So if we're talking about the maximum value, we need to think about, well, to find a maximum, I take the derivative, and then you figure out what?
When it changes from
yeah.
positive to
When it
negative.
changes from positive to negative. But if we're trying to find like the maximum amount,
Critical
then you
value.
also need to think about the
And
start
plus.
and the finish. So it's kind of like your
Oh,
absolute
yeah.
maximum. All right, so what's the beginning?
0.
0. The end is
Nine.
90, and we need to figure out at what point in time does it change from positive to negative. So we kind of have to do a few of those things. All right. So for this particular problem, I think I can write it here.
Gosh, deriving integrals.
So I need to
is
find the derivative. All right. So we have our function,
No, actually.
and you need to find the derivative of that. So if we find the derivative of f, well, what's the derivative of that?
Zero.
0.
Is that just negative the function?
Negative the function, because if I take the derivative of an integral, you're just left with
The function.
the function.
Times the derivative of the thing at the top. That's just.
So then
Alright.
just plus 8.
And then the derivative of at is plus 8. That's exactly right.
Hmm.
Alright, and if you're trying to find a maximum, you're trying to figure out when the derivative equals 0. And so in this case, and this 0 goes away. So how do I solve for t?
You put 8 on the other side, multiply by negative 2.
And then take the
Just literal. Alright.
Wait. Oh,
So we subtract the 8, the negatives cancel. Alright, times it by 2. So t to the 2/3 equals 16.
And then you take the
And then that's the same as the
square
cube root
root
of t
wait, cube root
squared.
of t.
So
So
then
you take
like,
the cube root of 16 squared. So
no, you take the,
You would take,
the cube root.
yeah, what
how do
was
you make this power 1?
It's the cube root of t squared.
Yeah, it's cube root of t squared.
What?
cube root? It is the cube root of t squared, but then you would have to
Yeah.
So we go on the
cube it, and then
take the square root.
and
Yeah.
then take
So
Yeah,
it's
cube
16
root.
cubed.
Alright.
16
So what some of you are saying was this?
So yeah, that helps me visualize,
Okay.
and then cube it all.
So yeah, you can cube it first, or you can take the square root first. Doesn't matter.
Take the square root first.
All right, square root first, make the number
Yeah.
smaller before you make it larger.
64.
So t would be 64. All right, but also over here, you could also just like 16 to the 3/2, which is the same thing as the square root of 16 cubed.
Is a power to a power? Do you multiply them together?
Whoa.
Okay.
All right, but you get 64 because if I take this
16, the number
t squared, I can take the square root of both sides to make it 4, and then cube the 4 to make it 64. And so you end up with t equals 64, but then that means it's either a max or a min. So now I got to figure out which one it is.
Plug in so smart.
All right. And so like we just said, we had a couple of values, and so here I'll write it over here instead.
And
All right.
it's not
So we
also
had
minus
64.
the cube root.
We also had the initial value, which is at the beginning and the ending point. So you need to figure out at f of 0 what's happening, at f of 64 what's happening, and at f of 90 what's happening. So at 0 and at 90, maybe one of those numbers is actually bigger than 64. So it might actually be a maximum at one of the endpoints.
And
So
then
that
you
was back when you did absolute max and min. So if I plug in 0 into my function,
8. Right?
that was 50. You're looking at this one, aren't you?
Oh yeah.
Plug it back
50.
into f.
Oh yeah. 50.
Because this is going to be 0 to 0 is 0. That's 0. So you start with 50. All right, there was 50 in the tank. 50 gallons anyway. All right, if I plug in 64,
It's not fun.
Oh, that's not fun. Yeah, that's.
and again, you have a calculator, so you would use that.
Gotta learn how
Or-
to do that. That's a great tool.
All right, so you would do the definite interval from 0 to 64 of this function, and then plug in 8 times 64
Have to.
with 50. So you get some number there. So what'd you get?